Of the three types of transformations, dilations may be the trickiest. This video is to highlight some key differences in vertical dilations and horizontal dilations. Let's begin. I have a function here. The parent graph is the red f of x. Notice how it's just the absolute value of x graph, like on your notes page that you took in class, and we've limited the domain from -6 to 3. We do that so you can definitely see the difference between a vertical dilation and a horizontal dilation. For example, you will note that on the side of my Desmos graph, I have a green graph where the 2 is in front and a purple graph where the half is in front. If we go compare the very endpoints of all three of these graphs, where they stop on both sides, we can tell that the biggest difference is not the x values where they end, because they're all sharing that same domain from -6 to +3. The main difference is the y values that are changed. So for example, from our parent function here on the red one, we see that there is a difference vertically between the red and the green function. How much different is it? Compare the x and y values. Here, our parent function is at 3, 3, where our transformed function is at 3, 6. This shows that our y value is multiplied by 2 to get to our new y value. That's why this multiplied by 2 y value makes sense for the 2 out front. Same can be said for the purple graph, where it now is at 3, 1.5. This shows that to get from the parent function to the transformation, we took it times 0.5 or 1/2. And that's where we can see that in the front of that function there. It's also helpful to remember, as you likely took notes on, that anytime you have a number outside your function, say in the beginning here, like this example, or even in your vertical translation out here, that will definitely go with a vertical transformation. Now we'll look at a horizontal dilation. So this time, we see our three functions. Our parent function is still the absolute value of x, graphed here in red, and its domain is restricted from -6 to 3 again. Let's compare the endpoints here now. Each of these very endpoints of all the graphs, if we look at them, here we have 3, 3, and here we have 6, 3. Let's stop right there. If we compare our parent red function to our purple function, that is actually this bottom one here. So we would see the only change in the function is that we have the half inside the parentheses. Now it might seem a little bit different. You might think, yes, it did shrink down, but we want to compare where they're ending at and what actually changed. So if we look across here, we see the y values. The heights are the same. What changed is the x value. So we went from an x value of 3 to an x value of 6. That would mean you multiplied times 2. A little bit crazy because in your equation you see a half. I like to say anytime there's a number inside the parentheses when you're using function notation, that transformation is going to be a little wacky, a little bit opposite of what you're thinking. In this case, the key word is a reciprocal. But for your time being, just think of it as, how did that x value change? And note that when there is a number inside the parenthesis by the x, there will be a horizontal dilation. This one happened to be horizontally pushed out twice as far. Whereas if we compare this point, this is actually at 1.5, 3. Again, the height didn't change. So if we look at the green function, we see a 2 here. Again, a little crazy because you would think going from the parent to the green function, we're going to actually take it times 0.5 or 1/2. That's a little odd, knowing that we have this 2 in front. But again, inside those parentheses, kind of a backward situation. So remember, if you're dealing with a horizontal dilation, that number will be inside those parentheses, whereas if you're dealing with a vertical dilation, that number will be outside the function, right out in front. This was likely in your notes from your teacher as well, but just as I summarized, here we can see if you ever have something in the front, wherever that star is, or outside here. So say you had a 5 and f of x and plus 2, you would note that these are both vertical transformations. This is going to go up 2, and this is going to make your slope go times 5. Over here, if we said f of 3x minus 7, this would be our horizontal translation. Remember, that would move it to the right 7, a little backwards, because you'd think backwards 7 or negative 7. And then this one would actually move it closer to the y-axis by a third.